Chapter 6B, or the second half of the unit, day 2. This first slide is a warm-up and review of the things that we worked on in day 1. So go ahead and pause the video and try these questions and then restart the video to see if you did things correctly. Okay, so when you solve an inequality, okay, this piece right here is the inequality. It's not an equal, but you solve it just the same way you would if it was an equal, unless you multiply or divide by a negative. So as I go through the steps of solving this question, you are not multiplying or dividing by a negative, it's a positive, and even though the answer turns out to be negative, okay, you would not flip the inequality sign. So once you get your inequality solved, then you have to graph it. And remember, you always need that key number of -2 or whatever your solution number ended up to be on your number line, along with one number or two numbers larger and smaller than your number. Then you put a circle representing that number, and if it's equal to that number, so it's greater than or equal or less than or equal, then you would shade that circle in. This one is not, it's only greater, so you shade the numbers, all the numbers on the number line that are greater than -2. So your arrow would be going to the right. On your second problem here, remember there's a -1, or when you have that negative in front, that's like having a -1. So as you start this, okay, you end up with -x is less than or equal to -2. But that's not your final answer, because remember there's a -1 here. So I need to divide by -1. And because I am dividing by -1, I have to flip the direction of the inequality to make it greater than or equal to 2. So the inequality that started out as less than or equal to became, and then I said flip it, and then I actually didn't flip it. So I have to flip it to greater than or equal to. So notice the inequality changed. So that should be your answer right here. And then you need to graph it. So again, that key number goes on here with a number or two larger and smaller. This time we do shade in because of that equal sign with it. And now I'm shading again the numbers that are greater. So those are to the right. This last question here is working on solving for y, because in slope-intercept form, we would be looking for y equals mx plus b. So to do that, I will add 6x to each side, and that gives me 2y equals 6x minus 4. Remember, we always put the x part first. Then when I divide by 2, each piece has to be divided by 2. I get y equals 3x minus 2. Then to graph it, remember, y equals mx plus b, this is my y-intercept. So I put my -2 on my y-axis. Then this is my slope, rise over run, so I have to go up 3 over 1. Up 3 over 1 to the right, since both are positive, and then I draw my line. All right, so we are going to be using those skills today to solve and graph linear inequalities. So instead of graphing y equals 3x minus 2, we'll have a greater than or less than in that, with the equals or just by itself. And then we're going to determine if a set of coordinates is a solution to the linear inequality. So this is just a quick little slide telling you, where could we see this? Well, actually, consumers can use linear inequalities to determine how much food they might buy for an event. Because if they have $20 to spend, then the cost that they can spend has to be less than or equal to 20. And so there's multiple different prices that you could have that would be solutions. So a linear inequality is similar to a linear equation, okay, but the equal sign is replaced with an inequality symbol instead, like less than or equal to, greater than or equal to, or just less than or greater than, etc. And then a solution is any ordered pair that makes the inequality true. So y is less than x plus 4 is an example of a linear inequality. And this ordered pair, 5, 4, is a solution to the inequality, because if I put the y value in for y and the x value in for x, I can see that 4 is in fact less than 9. So this ordered pair is a solution, but that's not the only solution. There are many others, and in order to show all the solutions, we need to be able to graph it. So that's our first thing we're going to work on today, is to solve and graph linear inequalities. So to graph a linear inequality, these are our steps. First, we have to solve the inequality for y, just like we did on the warm-up, because we need to put it in slope-intercept form, which is y equals mx plus b. And then we graph that boundary line. So we graph the boundary line using a solid line if we have less than or equal to, or greater than or equal to, because that equal sign is the key. We use a dashed line for just less than or just greater than. There is no equal with it, so we would use a dashed line. Then the final thing we do is we shade the half plane, or we shade above the line for y is greater than or equal to, and we shade the half plane below the line if it's less than or equal to. And then we can check our answer by checking a point and plugging it in to make sure it's making that inequality true. So we can pick a point that's part of the shaded region to make sure it's true. And sometimes we choose to pick a point that isn't and make sure it's not true, so that we can tell if we've shaded the right place or the right half plane. So let's start this first one here. All right, so the first thing I do is I put it in slope-intercept form, but this one's already solved for y, so I don't need to do that. So I start with my y-intercept plotted at 3, and then I use my slope to go a rise of 1 and a run of positive 2, so that's up 1 over 2, etc. Now I look. Notice I have this equal sign right here, so I should have a solid boundary line because of that equal part. Okay, then the last thing I do is I am going to shade above or below. Well, because it is greater than, I am shading above that line. So now what I'm going to do is check a point and make sure that I've shaded the right plane. So I'll pick a point, and I try to pick a point that has 0 as one of the ordered pairs. I personally like to pick a point that is part of the shaded region so I can make sure it is true. So that ordered pair right there is the ordered pair 1, 2, 3, 4. This is the ordered pair 0, 5. So I'm going to check that ordered pair by putting in 5 for y and 0 for x to see if it's true. And 5 is in fact greater than or equal to 0 plus 3 or 3. So I know that I shaded it accurately. Now down here it talks about that the ordered pair 0, 0 is a good test point to use as long as it's not on the boundary line. And you can use that ordered pair whether it's part of the solution or not. But if it's not part of your shaded region, then it should not be a true inequality. So again, if I plug in 0 for y and 0 for x, this time it should not be true because 0, and it is not, 0 is not greater than 3. So this one is not true. Okay, so that's just some helpful hints about checking your point to see if you've shaded it correctly or not. All right, example 2. I want you to try this one on your own and pause the video and go ahead and graph your boundary line. Make sure you pay attention to whether it's a solid or dashed, and then shade. And then restart the video to see if you did it correctly. Okay, so your y-intercept is 4 and your slope is -1, and so you're going down 1 and to the right 1, and it is a dashed line because there is no equal sign with your inequality. Then I am shading below the line because I am shading all the values that are less than that line, not on the line. So in this case, I can pick the ordered pair 0, 0 as part of my solution and make sure, and it should be true. So I'm going to find out, is 0 less than the opposite of 0? Well, 0 doesn't have an opposite, so it's just, is 0 less than 4? Yes. So I have done it correctly. Hopefully you did too. All right, in the next examples, we actually have to solve the equation for y first. Because it's not solved for y, I have to solve this equation for y or this equation for y. I'm going to have you try number 3 on your own and then check back to your notes. And we're going to do number 4 together. So after you do number 3, you can check the notes. You can pause the video and do that right now, and then I'm going to go through number 4. So I have to get the y by itself. So I need to subtract 3x from each side. So that gives me negative 2y is greater than negative 3x plus 12. Don't forget about your rules for solving inequalities, because in this next step, I have to divide by negative 2. And if I divide by a negative, I have to flip the inequality. So the inequality started out as greater than, and it's becoming less than because of that dividing by 2. So this now becomes y is less than 3/2 x minus 6. So I'm going to graph the line 1, 2, 3, 4, 5, 6. There's my y-intercept. And then I could go down 3 and left 2 like my original negative 3 over 2. Or I made both positive, up 3, 1, 2, 3, right 2. Up 3, right 2. Okay, my boundary line should be dashed again and not solid, because I don't have an equal with my inequality. And now as I shade, I am going to shade less than the line. Sometimes it's hard to tell. So if you put your pencil on the line, if you're moving up to go off the line, that would be above. If you're going down like this, that would be below. So y less than. And again, I can pick a test point, and you could pick 0, 0. And it should not be part of your solution, so it should not be true. I'm going to go ahead and pick another value. I like to have one of the components be 0, so I try to pick one on one of the axes. So now first name that ordered pair. That looks like it is 1, 2, 3, 4, 5. That's the ordered pair 6, 0. So now when I plug those values in, that would be 3 times 6 minus 2 times 0 would be greater than 12. We're seeing if this is true. And this becomes 18 minus 0, or 18 is greater than 12. So I have shaded it correctly. All right, so let's talk about graphing a point versus graphing a line. Notice that these two equations look similar. The only way you know what to do is this says graph the point, and this says graph the line. So if I'm graphing the point, I'm literally on my number line putting a circle and graphing that point. That is graphing the point x equals 3. Graphing the line x equals 3 is the horizontal line that goes through the x-axis at 3, or the vertical line, 1, 2, 3. Here it is going through the x-axis at 3. So this is graphing the line x equals 3. So now how do I graph the linear inequality? Well, I start by graphing the boundary line, which is a solid line because it has that equal with it. So I graph that boundary line of x equals 3, and then I'm going to shade all the values of x that are greater than 3. So where are the values of x greater than 3? Well, they're over to the right this time. So above and below works for non-vertical lines, and horizontal do actually follow that. So that's because of this greater than, just have to think about it intuitively. So This one, before we graph, we actually have to solve it for y. To solve this for y, I divide by 2/3. Remember, dividing by a fraction is keep, change, flip, or you end up multiplying by the reciprocal. And so this gives us y is less than 12 over 2 or 6. And you can do all that on your calculator. You can really just take 4 divided by 2/3, and that's totally fine. So now this line is a y line. So it's going to go through the y-axis at 6, 1, 2, 3, 4, 5, 6. And it's going to be a dash line because there is no equal with it. And now, again, because this is less than the line, where are the values less than that? Well, they're below this line. And I did not pick test points, but you certainly could verify with test points on those last two as well. All right, so the last thing we're going to work on today is determining if a set of coordinates is a solution to a linear inequality. So the solution is any ordered pair that satisfies the equation and makes it true. So if I look back to this example we did here, I picked one ordered pair and showed you that it is true. But there are lots of ordered pairs, like this ordered pair, okay, or this ordered pair. There's lots of ordered pairs that actually make that equation true and are solutions. So in this case, to determine, what we're going to do is just to substitute the x and y values. So substitute the x and y into each equation to see if each equation is true. They both have to be true this is for a system. Sorry, this is just to verify is a solution to, this should actually say the linear inequality. Sorry about that. We just have to plug it in to the equation to see if it's true. All right, so let's take a look at these. We want to determine whether this ordered pair right here, so is this ordered pair a solution? So to do that, I take the x value and plug it in for x, the y value and plug it in for y, and I see if it's true. So 5 minus 4 is 1. Is 1 less than 4? Yes. So yes, this is a solution. This one is. So now let's take a look at the second one individually. Okay, so now I'm going to check this one. So now I'm going to put the x value in and the y value in. So now -1 minus my y value of -4, is that less than 4? So remember, subtracting a negative changes to add the opposite. So this becomes -1 plus 4. Is that less than 4? Or this is 3. Is 3 less than 4? Yes. So this one is also a solution. All right, both of those ordered pairs end up to be solutions. Okay, now it's your turn. Pause the video, and I want you to see if you can tell if this one is yes or no. Okay, and then we'll check a different point, this one, for yes and no. And then you can restart the video to see if you got them correct. So when we plug this first one in, oops, sorry about that. So when we plug the y value in for y, and now we plug the x value in for x, we can see here 4, and then, oh, I've got two inequalities in there somehow. And this becomes -4 plus 1. And is 4 less than -3? No. So this one is not. Okay? That one is not a solution. Okay? And the second one, when we plug the x and y in, that becomes 1. Is 1 less than 1? No. 1 is equal to it, so that ordered pair is not a solution either. All right, so hopefully you can kind of get the hang of this. You can try that last one on your own and check back to the notes to see if you got it correct. We're going to move forward and just take a look at one application to kind of pull this all together. So I'm just going to work through this so you can kind of see what happens. You offer to mow your neighbor's lawns for $20 or to wash their cars for $10. Your goal is to earn at least $1,500 this summer. So write and graph an inequality that represents the possible number of lawns you would have to mow and the number of cars, Y, you would have to wash to reach your goal. So first of all, it told us that X is the number of lawns you would have to mow. So this is lawns that you would have to mow. And your Y value here is the number of cars. So this is the number of cars washed. Okay? So, can we write an equation? Well, we know, and I'm just going to kind of write this in general just so you can kind of get the hang of it. We know that the number of lawns mowed plus the number of cars washed has to be at least $1,500. So it could equal $1,500, but it'd be fine if you earned more. So it has to be greater than or equal to $1,500. So that's kind of where I'm starting. But how would I figure out how much it costs for, or how much I would earn for mowing the lawns? Well, I would take $20 times the number of lawns I mow, which was my X value, and add that with $10 times the number of cars I wash, which is the Y value, and that has to be greater than or equal to $1,500. So now I can just solve this equation for Y. So I am going to solve this for Y by subtracting 20x from each side. That gives me 10y is greater than or equal to negative 20x plus 1,500. Now I'm going to divide by 10. And what I get is y is greater than or equal to negative 2x plus 150. So now I'm going to label my scale here. So again, this is my x's, the number of lawns mowed, and this is my y. Notice that my y-intercept here is 150. So I can't go up by ones, but I probably can go up by fives. So 5, 10, 15, there's 20, 30, 40, 50. Nope, I'm not going to be able to go up by that because it will not get me there. So what I'm going to do is change that to tens, going up by 10, 20, 30, 40, 50, 60, 70, 90, 110, 130, 150, and that's as far as I need to go. So now when I graph this, I am going to put my y-intercept right here at 150. And then I'm going to go down 2 units and over 1. But I'm going by tens. So I'm going to go back to this original, going down 20. And I know this is kind of complicated for you, but that would be the same as negative 2 over 1. So I'm going to go down 10, 20, and over 1. Because my x-axis is going to be going by 1. So 1, 2, 3, etc. Okay, so I'm going to keep going down 2 over 1, down 2 over 1, which really means I'm going down 20 units and over 10 units. Oh, so these have to be actually going by tens. I'm sorry. Again, I know I picked kind of a complicated one, but I think that you will get the hang. You'll just kind of see the relationship to what some of these equations you're working with. So this would be a solid line. Okay, we wouldn't have negatives, so I wouldn't continue that line. And then I want to shade all the values that are greater than the line. So I'm going to shade over here. And all of the ordered pairs are all the combinations of the number of cars I would have to wash or the number of lawns mowed in order to reach my goal. So this question right here asks, is 50 lawns and 65 cars part of the solution? Well, this is 10. So 10, 20, 30, 40, 50. And then 65 is, here's 50. There's 65, I believe, is right here. So that is part of my solution. And we'll talk about some of those later on. So if that was kind of complicated, no worries. I just wanted to show you sort of an example. But that's the end.